Hello guys, welcome to Vision E-Tech. In the previous session, we had discussed variables and data types, right? Just recall what are variables and what are data types. Variable means it is a container to store the elements. See here, there are three types of variables. Instance variable, static variable, and local variable. Local variable means we can write the variable inside the body of the method, block, or a constructor. See here, I am writing the variable inside the method display. So we can access this variable inside the method only. Then if we want to call this variable means you want to create object of the class here. Then you can call. This is nothing but local variable. It means we can write inside the body of a method. This is nothing but local variable. Next, instance variable is nothing but inside the class but outside the body of a method. See here, I am writing the variable inside the class and I am calling outside the body of a method. Static variable means it creates a single copy of a static variable by using static keyword. Here I had created a single copy, that is y is equals to 150. Then you can use anywhere inside the method, inside the body, inside the class. You can use anywhere. That is nothing but static variable. It can share it among all instances of a class, of a method. It is called a static variable. Next is data types. Data types are nothing but it have a different sizes and values that can be stored in a variable. See, there are two types of data types. One is primitive and one is non-primitive. Primitive contains int, byte, boolean, char, short, and float, double, and long. These are the primitive data types. 10, 127, 10,000, true, 98. These all are stored in variables with different sizes. These are nothing but data types. And we have also discussed differences between float and double data types. Float means it occupies 4 bytes of memory. 4 bytes are nothing but 32 bits. And it accuracy of float is low and it follows single precision. Okay. Here we are using f as suffix. If we doesn't use f as suffix, it will show a compile time error. Because if you are creating a float value means you want to use f as suffix. It is mandatory. Double means it has a 8 bytes of memory. 8 bytes is nothing but 6. It is a 64 bit. And accuracy of double is high and it follows double precision. Here I am not using d as suffix. It is not mandatory to use d as suffix in double data types. Next one is typecasting. Typecasting is nothing but it will convert one data type into another data type. Okay, that is called as typecasting. There are two types of typecasting. One is widening typecasting and one is narrowing typecasting. Okay, here widening is nothing but it converts lower data type to higher data types. Remember the order of the data types by comparing the sizes. Here lower data type is byte and higher data type is double. Okay, we can convert lower to higher in widening typecasting. Narrowing typecasting is nothing but it will convert higher data type to lower data type. Here, in widening typecasting, it will perform automatically by a compiler. Here, in narrowing typecasting, the programmer want to perform. The casting want to perform in narrowing typecasting. Otherwise, it will show a compile time error. See here, it was showing a compile time error to cast a data type. See here, add cast to int. It was showing we cannot convert from float to int because converting lower data type to higher data type means it is not possible. So we want to add cast. By adding casting, we can convert higher data type to lower data type. This is nothing but narrowing typecasting. Okay. Let's go to our today's concept, operators. See here, in A is equals to 20 plus 10. Here 20 and 10 are nothing but operands. And plus symbol is nothing but operator. This 20 plus 10 value, it is nothing but 30, and this value will be stored in a variable. Next is in B is equals to A plus 30. Here I am using variable. I am adding variable and a value. Okay. This is nothing but operators. There are many types of operators: arithmetic operators, assignment operators, relational operators, logical operators, unary operators, ternary operators, bitwise operators, and a shift operators. Okay, let's see one by one. Arithmetic operators. All of you people know what are arithmetic operators means. It's a mathematical operators. Addition, subtraction, and multiplication, division. You know about these. But in Java, we can also use modulus operation. Okay. Operators are nothing but it is used to perform mathematical operations on numerical values. Okay. Let's see the example. So people will get the clarity about arithmetic operators and about modulus operator. Okay, now I'm creating another package. Inside this package, I will create arithmetic operator class. Okay. Here I am creating operators package. Inside this package, I am creating a class. Now, inside the operators package, I had created arithmetic operators class. Now, I am performing these operators. In A is equals to 100. Okay. Now, in B is equals to 200. Now, I have stored the values inside the variables. Now, A plus B. It is nothing but the output value is 300. A minus B means 100 minus 200. What will be the output? The output will be minus 100. Okay. And next is multiplication. Multiplication is nothing but what will be the output? 100 into 200. It will be 20,000. Okay. This will be the output. Division. You know about division, right? See, 100 divided by 200. What will be the output? 100 divided by 200 is nothing but the value is 1 by 2 and 1 by 2 value is 0.5. Is the output will be 0.5? Let's see after that. Next one is modulus. Okay. Modulus is nothing but it will shows the remainder value. Division is nothing but it will show the quotient value. But in modulus, it will show the remainder value. Means see here, 100 modulus 200 means first divide it. 100 divided 200 means it will show the remainder value. Here, what will be the output? It will shows the remainder value. But here it is possible because the numerator value is lower than the denominator value. So, it will show 100 as an output because the value, numerator value is lower than the denominator value. That's why it will show the numerator value as an output. 200 modulus 100 will be there. Then what will be the output of modulus here? Let's show 0 as output. Okay, let's check. See here, A plus B is 300 and A minus B is minus 100 and A into B is 20,000. Here A divided B. Here we will get the output as 0 Here we have got 0.5, but it will display only numerical values because we are using int data type here. If we use float data type, it will show the 0.5. We are using int data type, right? That's why it will show 0 as an output. Okay? But see here, modulus. A modulus B is nothing but 100 is lower than 200, is smaller than 200. That's why it was showing 100 as an output. If we perform B modulus A, see, it will show 0 as remainder. The output will be 0. See, the output is 0. Okay. And now see another example. In x is equals to 20. In y is equals to 3. Okay. I am dividing these values. X divided by y. Okay. Now what will be the output? Here 20 divided by 3. It will become 6. If we calculate means we will get output as 6.666 like that. It doesn't show these fractional values. That's why it was showing the output as 6. Now, I am performing modulus operation here. X modulus y. X modulus y means, see here what will be the output? It will show the remainder value, means anti modulus 3. It will show, we will get the remainder as 2, right? Now see the output. See, the output was displaying as 2 because 20 modulus 3. It will show the remainder. Remainder is 2. Okay. These are nothing but arithmetic operators. Next one is assignment operators. Here assignment operators are nothing but is equal to operator, less is equal to operator, minus is equal to operator, multiplication is equal to operator, division is equal to operator, and modulus is equal to operator. Okay. Here assignment operators are nothing but it assign the values to the variables. Okay, let's see the example. Now create another class, assignment operators. Okay. Okay, now int a is equals to 100. Int b is equals to 200. Okay. Now print the a and b values. A, I'm giving space in between a and b. Now see, a, b values are 100 and 200. Right? Okay. Next, I'm using plus is equal to operator. It means a is equals to a plus b. Okay. This a plus b is nothing but 100 plus 200. That will be stored in the a value again. Now see the a value. What will be the a value? Now see the a value. What will be the output of a value? It will be 300. Okay. B value remains 200. Same. Okay. Now see a. Before assigning the b variable, a value is 100. After adding, the a value is 300. Right? Okay. B value is same here. I am printing B value. B value is same. Okay. B value is 200. In the same way, we can perform A minus is equals to B. Means the subtraction will be for them here. Okay. Now A value will become change. See here, A is equals to A minus B. It is the meaning of this operation. Okay. Now A minus B is nothing but 100 minus 200. The output will be minus 100. Okay. A value is minus 100 and B value is same. If I want to change the B value, B minus is equals to A. Okay. Now the B value will be changed. See here, A plus B. Now guess the output. What will be the output of A and output of B? Save it 100. See here. It means B is equals to B minus A. Now just guess the output. Okay. See now. It was showing 100, 100. Now the value of A remains same here. And B was changed. 200 minus 100. It is nothing but B value is changed here. Okay. The same way we can also perform multiplication, division and modulus. Okay. Now I'm performing multiplication. It means it will remain same. Multiplication remains same. A is equals to A into B. Okay. If I perform B division is equals to A means if I perform the operation B is equals to B divided A. Okay. It can show us the output. Okay, right? These are nothing but assignment operators. It will assign the value to the variable. It allows you to store a value in variable, inside the variable. Okay. These relational operators. See here is equals to and not equal to, greater than, less than, greater than or equals to, and less than or equals to. These are nothing but relational operators. It is also known as comparison operators. Means we can compare each and every value here. It will returns the Boolean value. Boolean value is nothing but true or false. Okay. For example, if I take A is equals to 10 and B is equals to 20. Here 10 is less than 20, right? If I perform the operation A is less than B, then it will return the output as true. If I give A is greater than B means 10 is not greater than B. Returns the output false. Okay. Let's see the example. Creating another class. See guys, here I am creating another class for each and every operation. New class for each and every operation. Because of your understanding purpose. If you write all operators in one class, you people may get confused at some time. So please be clarity and don't get confused on each and every topic. Okay. I'm creating relational operators class. Okay. Now int A is equals to 20. Guys, I'm performing here only int data type. It's not only for int. We can also perform float, long, double also. Okay. Next concept we will perform float also. Okay. B is equals to 10. Here now A is greater than B, right? I'm printing this out. A is greater than B. What will be the output? The output will be true because A is greater than B means 20 is greater than 10. Okay. Now save it and run. See here the output was true, right? For example, in C is equals to 20. Now I am printing A is less than C. What will be the output? It will return false, right? See the output. See, it was displaying false. Now, this is out. A is equals to C means it will return true. Okay. For example, A is greater than C means it will return false. Greater than or equal to C means what will be the output? It will return true or false. It will return true because I am using greater than or equal to. If it is greater than, if it is low, if it is greater number, it will return true. Or if it is equal to, it will return true. Otherwise, it will show false, right? That is the meaning of greater than or equal to. It will satisfy. Running. See the output. It was showing true. If I perform less than or equal to means also, it will show true as an output because 20 is equals to 20. See, it was showing true. It will return true either it satisfies less than function or it satisfies is equal to function. Okay? So you got the clarity, right? Okay, another operation is not equals to. A not equals to C. Okay? What will be the output? It will return false because 20 is equals to 20. See, it was displaying false. These are nothing but relational operators. Means it will compares the value. It was comparing the value right here, A and B and C. The comparison was happening in between A and B and C. Okay. And the main thing is the output will be written in a Boolean format. And next is logical operators. Here the logical operators are logical AND, logical OR and logical NOR. These are used to perform the logical operations on Boolean values. Okay? It will return the Boolean value as output. Just remember this truth table of logical operators. See here logical AND means if both statements are true, it will returns the true. Okay? See here, A value is true and B value is true. If we perform the logical AND operation in between these two, it will returns true. Otherwise, it returns false. See, the name itself says and. And means both the values. Okay? If both the values are true, it will returns true. Otherwise, false. Logical OR. OR means if the both value is false, it will return false. Otherwise, it will return true. Okay? Logical NOT. Logical NOT is nothing but it is complement to that value. Complement is nothing but if the value is true, it will return false. If the value is false, it will return true. Okay, let's see example. I am creating logical operators class. Okay, now in A is equals to 200, in B is equals to 300. Okay, now see now A is less than B. Okay, this is my condition. And I'm performing AND operation. A is equals to B. Okay. This is my condition. Here I am performing the logical operators in between these conditions. Okay. Now say A is less than B. Means 200 is less than 300. It will return true or false. 200 is less than 300, right? It will return true. Okay. Next condition is A is equals to B. Here A is 200. B is 300. Okay. Now it returns false. The condition is false because it is not equal. See here. One condition is true and one condition is false. Now I had performed logical AND operation in between this. Now see what will be the output. One is true and one condition is true and one condition is false. Okay. Logical AND means the both statements are true, then it will return true, right? Otherwise it return false. Now the output will be false. Okay. See. See the output. Output is false. Right? The same way, now logical OR. I am performing same conditions with logical OR. See. Okay, logical OR. Now, same conditions, but I am using logical OR operation. Okay, now what will be the output? Logical OR means the both statements are false, it will return false. Otherwise, it returns true. Now, one condition is true and one condition is false. The output will be true, right? See. See, the output is true, okay? Non-logical, not. I'm performing same condition here. See. Here I had used a logical AND, right? This output will be true, right? I am performing logical NOT operation. Now what will be the output? False. False is output, right? Logical NOT is nothing but if the output is true, if we perform logical NOT for that output, it will return false. Save and run. The condition is true. I am performing NOT operation, so it will return false. See, false. Okay? These are nothing but logical AND, logical OR and logical NOT. It will be forward in between the conditions. Okay? It will return the Boolean value as output. Unary operators. See, unary operators are minus, not, increment and decrement. These are unary operators. Unary operators means it performs operations on only one variable or a value. Okay. These operations will be performed on only one variable or a value. Okay. Let's go to example. Now I'm creating unary operators. Now see, int A is equals to 100, int B is equals to 200. Okay. Now, first one is unary minus. Okay. For example, minus A. I'm giving minus A. Means the output will be minus 100. Right? This is the output. In the same way, minus B means it will display minus 200. Okay. See the output. See, the output is minus 100. Okay. And next one is unary not. Unary not is nothing but we have seen logical not. Right? No? It was showing error because unary not is nothing but it returns true or false value. Right? But I'm giving here integer. The previous we had used not value on conditions. This condition is nothing but, this condition value is true. We are not on Boolean value, right? That's why it doesn't show any kind of error. But in unary operators, I am directly performing on int. That's why it was showing an error. See, the operator not is undefined for an argument type int. That's why it was showing error. Now, I am giving boolean b is equals to true. Okay? Sorry, boolean b1. Okay. I am using p1 variable here. Okay, see, the error is gone. It will return output as false. Right? See the output false. If I return true here, if I return false here means it will return true. Okay? This is nothing but unary not. Okay? Next one is increment. Increment is nothing but we have this is incrementation and minus is decrementation. We have two types here. Post increment and pre-increment. Okay? Now int x is equals to 12. Okay. Now I am printing x value. It will print 12. Okay? You know this. Now I am incrementing the value. Now what will be the output? This is called post incrementation. Post incrementation. Okay? Now guess the output. Post incrementation is nothing but if the operand is incremented but the previous values is retained temporarily. Okay? Until the execution of statement. Let's save it and run. The output, the x value is 12. After incrementing, it was displaying 12. But it gets updated before execution of next statement. Okay? Now, I'm executing another statement. See here. Now the x value is 30. Right? See. This will be not executed in a single statement. It gets updated before execution of next statement. Okay? See? Since pre-incrementation. Okay? This is called pre-incrementation. We have used it before the variable. We have used increment operation before the variable. This is nothing but pre-incrementation. Okay? Show instantly without getting any update. Operand value will be incremented instantly. Okay? Now what will be the output? See here. Now the x value is 13. After incrementing, it will show the output as 14, right? Let's save it and then was displaying 14 as output. Okay. Will increment the value instantly. Okay. Post incrementation is nothing but it will update before the execution of next statement. Okay. Now decrementation. Same way can also perform decrement. Now the y value is 10. Right? Y minus. This is nothing but post decrementation. Okay. Now what will be the output? It will display 10 as output. This will also display 10 as output. It gets updated before execution of next statement. That is nothing but post incrementation or post decrementation. Okay, it will update only execution on next statement. Let's see, it will display state. Save it as This is the y value. After decrementing y value, it was showing 10, right? But it was decremented. It was decremented into 9. Now see, now print the y value. Will show 9 as output. See, it was decremented. Okay? It will show, it will get update before execution on next statement. Remember this, it will get update before execution of next statement. Okay? The same way, pre-incrementation. Now, what is the y value here? Y value is 9. If we use pre-decrementation, it will show the output as 8, right? Let's say it under. See the output. It was showing 8. Okay? Got clarity on this? This is called pre-decrementation. Post-incrementation and post-decrementation means the value gets updated before execution of next statement. Okay? Pre-incrementation and pre-decrementation means the operand value is incremented instantly. Okay? We don't want to print again. Okay, these are nothing but unary operators. See, we are performing on single variable here. Here I am performing this minus operation on A variable, not operation on B1 variable, and incrementation on X variable and decrementation on Y variable. Here I am performing my logic on single variables, bitwise operators. See, bitwise and bitwise or bitwise XOR and bitwise complement. These are the bitwise operators. These are used to perform operations at the bit level. Means, I think you know all the binary numbers of it, decimal numbers, right? Okay, let's see example. Creating bitwise operators class. Okay. So, you know the binary numbers, right? Like for for the value of 1, it will give 0, 0, 0, 1. For the value of 2, it will give 0, 0, 1, 0. The value of 3 will show 0, 0, 1, 1. Okay. For 4, 0. These are the binary numbers. Okay. For each and every value. Okay, for each and every value like this, we have a binary numbers. These are we can calculate these by doing LCM of these numbers. Okay, right? Okay, now not only for these numbers, we can also calculate like a 2-digit number, 3-digit number also by doing LCM of such numbers and by calculating remainders. Okay, let's see the example of bitwise operators. We can calculate the bitwise operations by using these binary numbers. That's why I mentioned these values. Int a is equals to, for example, I am taking 4, int b is equals to 5. Okay. Now I am performing a bitwise and b. Here 4 is nothing but 0, 1, 0, 0. 5 is nothing but 0, 1, 0, 1. Okay. Now bitwise and is nothing but, this is called multiplication. Okay. See here 0, 1, 0, 0 having by having 0, 1, 0, 1. Okay. Multiply these numbers. What will be the output? See, if we multiply these, 0 into 0 is 0. 1 into 1, 1. 0 into 0, 0. 1 into 0, 0. Okay. This will be the result of 4 bitwise and 5. Right? Okay. Now 0, 1, 0, 0. Decimal number is 4. 4 will be the output of A and B. Okay. Let's save it and run. See the output. 4 is an output. Okay. In the same way, we can also perform bitwise order. Right? Nothing but addition. Okay. Now see, now add this 0, 1, 0, 1. Okay. Now, if we add this means what will be the output? See, 0 plus 0, 0, 1 plus 1. Here it's not 2. These are the binary numbers. 1 plus 1 is 1 and 0 plus 0, 0 and 0 plus 1 is 1. Okay. Now the value is 5. What's the result? Output will be 5. Save it and run. See here the output is 5. Okay. We can calculate not only these numbers 1 to 8, we can also calculate 2 digit on 3 digit numbers also by doing LCM with reminders, right? Next one is bitwise XOR. XOR nothing, XOR B. Okay. Now see what will be the output. But in XOR, if we A value have 1 and B value have 0, then output will be 1. And if A value is 0 and B value is 1, the output will be 1. Remaining are false. See, 0, 1, 0, 0 and 0, 1, 0, 1. Okay. Now, XOR means if there is 0 and 0, the result is 0. 1 and 1, the result is 0. See here, 0 and 0, the result is 0. Now, 0 and 1, the result will be 1. Okay, this is nothing but XOR. See here, the result is 0, 0, 0, 1. What's the value of 0, 0, 0, 1? Value is 1. Now, output will be 1. Okay, save it and see here, the output is 1. And next is bitwise complement. We can denote bitwise complement by using tit operator. Okay, it will returns 2's complement of our given input. Okay, 2's complement. It will return output in 2's complement. That is in negative format. Okay, now see, I'm using this complement in a variable. Okay, a is 4. 4 value is 0, 1, 0, 0. Now, just adding 1 to this binary value means what it will happen plus 1 means 0, 1, sorry, 0, 1, 0, 1. Okay, by adding 1, we can get this. 0, 1, 0, 1 is nothing but the value 5. Okay, now the output is 5 in negative format. Okay, means the output is minus 5. Save it and run. See the output minus 5. Ternary operators. Here, this is a ternary operator. Question mark. Okay. When we will use this operator means if we want to express any conditions, then we can use ternary operators. Okay, this is also known as conditional operator. If we want to use any conditional statements, then you can use ternary operators to concise our code. Types of ternary operators. See here, we want to write our condition here. Okay, if the condition is true, this statement will give output. Okay, if the condition is false, this will be the output. Let's see example. A is equals to 100, B is equal to 200. Okay, now if B is greater than A, okay, if the condition is true, just remember the syntax here. The condition is true, then A plus B will be output. If the condition is false, A minus B will be output. Okay. Now this I want to store in one variable in result. Okay. Okay then. See. Now I'm printing my result. What will be the output? Guess the output. B is greater than A, right? Means 200 is greater than 100. This condition is true. If the condition is true, this statement want to print. If the condition is true, see here, A plus B is nothing but 300. The output will be 300. If the condition is false, A minus B means, if the condition is false means A minus B will be the output. Means minus 100 will be the output. Now the condition is true now. That's why 300 will be the output. That's save it and done. See, 300 is my output. If I give B is less than A, if B is less than A, means 200 is less than 100, it is false. Okay. Now the output is minus 100, right? Save it. Okay. See, minus 100 is my output. Okay. Now you got the clarity on ternary operations. When we use ternary operators, if we want to evaluate any conditions, then we can go through ternary operators. Okay. And next is shift operators. This is silent right shift and silent left shift. These are used to shift the integer values from left to right and right to left. These are used with integer types. Let's see examples. Now, I am creating another class shift operators. Okay. Now, equals to 4. Okay. Now, okay, 2. Here, I am doing right shift for 2 times. Now, guess the output. Here, A is 4. 4 means binary value 0, 1, 0, 0. Here it is a shift operator. Shift operator means it took 8 values, 8 bits. Now, right shift means here I am ignoring these 2 values and will be added into the right side. See now, 1, 0, 0, 0, 0 and 0. Okay. Here, I ignored these 2 values. Right? And what I want to do? I want to add here 0 and 0. Okay. Now, I wanted to calculate means because this is 2 power 0. 2 power 0. And this 0 value is 2 power 1. Okay. like that. 2 power 2, 2 power 3, 2 power 4, 2 power 5, like that we want to calculate this input. Now, 2 power 0 is nothing but 1. The value of 2 power 0 is 1. So, the output of A night shift 2 is also 1. Save it and run. See here, the output is 1. In the same way, if you take int A is equals to 5, means if you want to do right shift 2 times for value 5, it will also show 101. 5 means 101. If I ignore 01 last here, the 1 will remain here. In the same way, we can also get value 1 as output to 5. See? 5. Save it and then see the output 1. Okay? And next one is left shift. See. Now, to the same number. I am performing left shift 2 times. Here, A value is 5. Okay? Now, taking 8 bit, 5 means 0, 1, 0, 1. I want to perform left shift. Now, I am ignoring these two numbers. Okay? Now, in right shift, I had ignored these two numbers. In left shift, I want to ignore these two numbers. Okay? Now, I am shifting this 1, 0, 1, 0, and 0, 0. Okay? Now, I ignore these numbers, these two numbers. Where I want to add? I want to add in left side. Okay? Hope you got clarity now. Okay, now what we want to do? Now what we want to do? We want to calculate like 2 power 0, 2 power 1, 2 power 2 like that. Here 2 power 0. This value is 2 power 0. Okay? And the second 0 is 2 power 1. This is 2 power 2. Okay? 2 power 2. And next 0 is 2 power 3. And next one is 2 power 4. Right? 2 power 4. Remaining all are zeros. Now we want to add these two. Means what will be the output? 60 plus 4. 20. 20 will be the output. Okay? Just save it and run. 20 is the output. Okay, hope you have got clarity now. It's a right shift and these are left shift operators. Okay? These bitwise operators and shift operators are completely based on binary numbers. In today's session, we had completed operators and types of operators. Arithmetic operators, assignment operators, relational operators, logical operators, unary operators, ternary operators, bitwise operators, and shift operators. So guys, please do practice each and every concept, analyze each concept theoretically and practically. Okay. In the next session, we will go through control statements. Okay. Thank you. Thank you so much for watching.